A box of mass 8 kilograms rests on a horizontal, rough surface. A string attached to the box passes over a smooth pulley and supports a 2 kilogram mass at its other end. When the box is released, a frictional force of 6 Newton acts on it. What is the acceleration of the box? Alright, so this is the box and it starts to move because it's released from rest and we need to find the acceleration. So we can use the formula F is equal to ma for acceleration, but we need to know the force, and this is the resultant force. Remember, in this formula, in the Newton's second law of motion, F is equal to ma, this F is the resultant force. So we need to find the resultant force first. Now let's look at the box and let's look at all the forces acting on the box. First of all, we have a frictional force, which is given as 6 Newton. Right, the friction force is given as 6 Newton and it's going to be to the left. The reason it's to the left is because the box is moving to the right. And frictional forces always act opposite to the direction of motion. Okay, what else do we have? We also have a forward force, which is actually the tension along the string. Whenever you see a string, there must be a tension force acting along the string, and the direction of tension force is always directed away from the object, away from the box. Okay, now we need to find the tension. How to find the tension force? This string is further attached to a smooth pulley, and at the other end of the pulley you have a 2 kilogram mass. So this tension is actually due to this little mass hanging down. So I can say that this tension is equal to the weight of this box. W is equal to 2 multiplied by 9.81. So the tension in this string is equal to 2 multiplied by 9.81, which is 19.62. 19.62 newtons. So I got the tension. Tension is 19.62 newtons. And now I can find the resultant force acting on the box. The resultant force, let me write it as Fr. It's going to be equal to 19.62 minus 6, which gives me 13.62. 13.62 newtons is the resultant force. Now I can move back towards my second law of motion and substitute all the values. 13.62 is equal to the mass of the box, 8 kilograms, multiplied by the acceleration. Okay, but we are missing one thing over here. The mass is not just 8 kilograms, it's 8 plus 2. Because we are applying this equation of motion to the entire system basically, so the combined masses should be considered. The mass of the big box and the mass of the small box. And now let's solve this equation and you should get your answer. After solving this equation, you would get A is equal to 13.62 divided by 10, and that's equal to 1.4. Yeah, it's actually equal to 1.362, and you can round it off to 1.4 meters per second square. Option number A is your answer.